Okay, let's do chapter 14. So the first three questions here are really just conceptual. The first one is what is the difference between common cause variation and special cause variation? And if we look on page 14-2, we can read that and find that answer. The second one here is, or number 3, what is the difference between attribute control charts and variable control charts? And the last question here, concept question, is why are X bar and R charts used together? Okay, for the first one here, if we look on page 14-2, we can actually do that here. 14-2, does that work? It does. Okay, so we're into the control charts chapter 14. And 14-2 here, right here, explains the two types of causes of variation. We've got special causes, and those are usually assignable to some particular thing that's happening, that's some sort of phenomenon. Or we have common causes of variation, which is the inherent variability that exists in a process, the random error and so on. And these are just chance causes. And what we're after is these special causes. If there's a special cause variation, if we've identified something that has the characteristics of a special cause variation, then we may want to do something about it. If our level of random causes of variation, there's nothing out of control, but our random causes of variation those random causes cause the variation to be too large, to our liking. Then we have to actually make some more wholesale modifications to the process to improve quality. So if we go back to the question here, common cause versus special cause. So common cause causes are random, and special causes are due to assignable causes. So the next question number 3 here, is what's the difference between attribute control charts and variable control charts? We can look on page 14-4 to see the definition of a P chart, which is a control chart. And then later on in section 14.5, we learn what control charts are. We learn what range and the range and mean, the X bar and R charts. So attribute control charts are used for categorical or discrete variables. That's the key here. These are for categorical. We use them mostly for that. And when we have range and mean charts, we're looking more at measuring something. These are more continuous variables, so we're looking at a varying mean. And we use range. We have the range chart, which is the R chart. We use that first to determine if the variance, if the range is in control. If the range isn't in control, then the X bar chart doesn't really mean much, because it's not a normal. It's not normal. So we use range to make sure the range is in control, and we use the mean chart to make sure that's in control. So question 4 in these concepts, why are X bar and R charts used together? Well, I answered that up here. Okay. Question 5. This question uses the rubybird.xls file, which is included in the assignment and phstat. And in this question, we're going to use P charts to monitor the market share of a product and to document the effectiveness of marketing promotions. Market share is defined as the company's proportion of total number of products sold in a category. And if the P chart is based on market share, then we can look to see if it's an in control process, and if it is in control, the proportion of share or market share, then we'd say that the marketplace is stable and consistent. In this example, we're going to actually we've done a study. We've collected some sales data, and the first 30 days of the data indicates the total number of cases of discs sold and the number of Ruby discs sold. So it's a proportion of Ruby discs and the total number of cases. So there's cases of discs from other companies or manufacturers also. And then the final 7 days, so there's going to be a total of 37 days of data in this spreadsheet. The final 7 days were taken after RubyBird launched a major in-store promotion. And so we're going to use control charts to see if the in-store promotion was effective. And so let's see how we do that. We're going to look to see if over the full 37 days, if it appears the process is not in control, and that it is because of a special cause, the special cause variation in the marketplace, and we would conclude then that it would be because of our in-store promotion. So first, let's open up the Ruby spreadsheet. Okay, we've opened up our RubyBird spreadsheet here, and we've got phstat loaded up. And so the first thing we're going to do is we're going to create a control chart for the first 30 days. And so that means it's only up to here. So let's do add-ins, phstat, and we're going to do control charts, pchart, and this thing pops up. And for the nonconformance and cell range, we're going to do the data we're looking at, the special data, and we're only going to go up to 30. And then for the sample groups, that's the total sample here. So and the sizes do vary. You notice that there are different numbers here in the second column. So I'm going to click here, and I'm going to also, these are the total cases. So this is the total samples up to 30. And I'm going to name first cell contains label. I'm going to name it first 30 days and click OK. And this is the P chart that comes up. First 30 days. You notice that it's it looks in control. There's no observations above or below the critical levels here, the upper control limit and the lower control limit. And let's go back to our assignment, and so it looks something like this. And so the second question, okay, so that looks good. The second question is the market share for RubyBird in control before the start of the in-store promotion? Yes, we've just answered that. Because none of the 4 out-of-control conditions is satisfied. If we go back to our Exam 1 study guide, we recall these 4 diagrams here. These are the 4 rules. This one indicates that there is an observation outside one of the control limits. This one indicates that we've got 8 in a row on one side or the other of the mean. This indicates you've got 8 in a row all going in one direction. And for this one here, a couple of ways to interpret this, but when you add up the number above with the number below and compare that with the number below, if you end up with something that's less than -8 or above +8, then that indicates an out of control condition. None of these exhibit any of those conditions. So we would conclude that it is in control before the in-store promotion. Okay, next we're going to extend the control limits to include 31 through 37, and this English here is not very clear. This suggests you only do 31 to 37. I'm going to actually do all three of them so we can take a look at what they look like. But what we are asking for here is from day 1 to day 37. So let's create that control chart. Let's go back to the spreadsheet and go back to our data. And this time we want to do all of the rows. Let's do add-ins, phstat, control charts, pchart, and this thing pops up. And our nonconformances cell is now the entire column to 37. And size varies. That's going to be total cases down to 37. And this is going to be all 37 days. And this is just indicating that it looks like there is something out of control. And it looks like this. And we see that there's a lot of problems with this chart. It looks like this, and it resulted in the process overall being out of control. All of the first three out of control conditions are satisfied. Only one needs to be, and but we also notice that it's out of control in what we might say is a preferred way. So we see that there's 8 in a row. 1, 2, 3, 4, 5, 6, 7, 8 in a row below the mean. We've got outliers here, and we've got an outlier here. And also, you know, when you add all these up, that also indicates out of control too. There's only, in this first area here, there's only just a few that are above, and most of them are below. Well, that's because it's counterbalanced by the strong performance in the last 7 days. And so, so that's exactly what we wanted. The process is out of control. It's out of control in a good way, caused by, we would conclude, by the promotion. So explain why it is necessary to generate 2 P charts. Well, it's because we first needed to determine the original process was in control. If the original process was not in control, then then why go any further? We need to get that in control first before we can compare it with something else. And so we demonstrated that, and then once we add the last 7 days, we see that it goes out of control for that reason. And the E here, the last one, is explain also why it would be insufficient to compare the chart with the first 30 days with a chart for just 31 through 37. Okay, so if we actually do 31 through 37, we get something that also looks like it's in control. So this pops up, and the first non-conforming cells would be these 7. First cell does not contain a label. Size varies, does not contain a label. 32 to 38 after promotion days. And that looks like this. And so for the promotion days, we see that the chart is in control. For the first chart is in control. If we did not do the second chart, it would not be as apparent, but we should still notice that the first 30 days, the chart's in control, and the mean is someplace between, it's about 27 or 28, or 0.27 or 0.28 is the proportion. When we look at the last chart that we created, we see that the proportion is up, it's up over 4.5, or about 4.5 or so, and the process appears to be in control up here. So we can draw possibly a similar conclusion if we do, in fact, look at compare the first 30 and the last 37 and the last 7, but it's clear from this chart that something is happening. Okay, the last part of this is, in this particular problem, is the process of being out of control undesirable or indicates a problem that needs to be corrected? And in this case, the out of control process is desirable and there's no problem. And we wanted to see a sufficient improvement, and it looks like we have.